And sorry we have to learn a lesson the day before our winter break, but we had, I've lost 6 days of instruction this year so far with iReady evaluations. And so, unfortunately, we have to get this lesson in. This is a lesson we're going to, most of it's review, but there's one part that's new, and I want to make sure you guys have learned this, because when we come back, we're going to be done with 3.8. We're going to start new stuff. All right, so can you guys please copy this in your notes for me? You guys just go ahead and copy this problem right down here in your notes. So we're going to solve the system. And the first few steps are a review of what we've been doing for a few lessons already. Let's give you a second to copy that down. So we're going to solve this system using the substitution method. In order to use the substitution method, we have to take one of our variables, either the top x, top y, or bottom x, or bottom y, and we have to isolate one of those. We have to get them so it says like y equals or x equals. So I want you guys to think about this. Which one would I isolate? Think about that. Actually, ask your neighbors real quick. Which one would I isolate? All right, so what did you guys say? Any volunteers? Which one would I isolate? Yes, sir. The bottom what? X or Y? Why the bottom Y? Anybody know? Tori, what do you think? The top one? Okay, you are right about one thing. I would isolate the top Y. Take a look at that. What's different between that Y and this X, and this Y? What's different? Tell your neighbor, what's the difference between those? Yeah. So some of you are saying isolated by itself, and I know what you mean, but it's not by itself. It actually has no coefficient. But it's not isolated yet. Isolated would mean it says Y equals and then some stuff. Nothing else would be on the same side. So it's technically not isolated, but you're thinking the right way. Meaning, there's no number in front, or no what? No coefficient. That's right. That's why you guys want to isolate this Y and not any of these other variables. You could. You're not wrong to do that. You're just making too much work for yourself, including fractions. Okay? So if we select the equation that has a variable with no coefficient, that's the smartest option you can take. That's the least amount of work. So now I'm going to take this equation, which I got from here, and I'm going to isolate this Y. So what do I have to move, everybody? The negative 2x. What's the opposite of negative 2x? So what am I going to do to both sides? I'm going to add 2x. You guys remember the name of that property? Say it out loud if you know it. Not division property of equality. Nice, Tucker. Addition property of equality. So when I add it to both sides, this is what happens. This equation is the exact same line as this equation. They're the same equation. I just move stuff around using a property of equality. So everyone get caught up on your notes now. So this is the same as this. Now that I've taken one equation and I've isolated one of the variables, I can substitute it into the other equation. You don't want to plug it back into itself. You want to plug it into the other one. So in other words, you guys are going to say this equation again. You're going to rewrite this. But instead of putting a Y right there, you're going to put this stuff in parentheses instead of the Y. So I want you guys to try that in your notes right now before I teach you how to do it. Write the next line. Rewrite the other one, but substitute the Y. Substitute this in for the Y in parentheses instead. Everybody try that now. Anyone willing to try that to say what I should have written next? Okay. Caden, you want to tell me what I should have written next?
4x plus -2 in parentheses 2x plus -1 equals 2.
Nice job. Very good. Bless you. And so Caden plugged it in correctly, and he even did the rule for subtraction, didn't he? And I think I skipped that in my notes. Yeah, I shouldn't have done that. Your next line should look like this. I'm going to do the rule for subtraction like Caden said. I got 4x. I'm going to do add the opposite right there. I'm going to draw two sticks. So my minus sign becomes a plus, but I have to change the sign for that +2, so it becomes -2. So I did the rule for subtraction because that was subtraction. I'm going to do it here too. And when I do that in the inside, I'm going to end up getting 2 plus -1. But inside these parentheses, I put another set of parentheses. So that's why what I do is I change these parentheses right here into brackets. Because we alternate parentheses and brackets so it doesn't look so confusing. So all we did is rule for subtraction, didn't we? Now we're going to distribute. So when we distribute this, it's going to look like this. We're going to copy this part down that we're not using. I repeat, I am not going to add 4 and -2. First of all, they're not like terms. Second of all, I have to distribute before I can combine like terms, even if they were like terms. So I got to distribute first. So now I'm going to go like this. I'm going to go -2 times 2x, which is -2x. I'm going to go -2 times -1. Negative times negative is positive. 2 times 1 is 2. You guys see where that came from right there? So now, I copied the rest of my equation. I always copy the stuff I'm not using, right? I just do one step at a time. I distributed right there. Okay, so I won't get caught up in your notes. If I already lost you, please raise your hand and let me know the line. Which line? We'll call this 1, 2, and 3. Which one is confusing to you? Was it substituting, or was it distributing that didn't make sense? Okay, after we distribute, ask your neighbors, what do you do next, guys? Combine like terms. What are my like terms? These two. Now, they're on the same side, right? So don't do inverse operations. Just add them the way they are. Can you guys do teams for me real quick? Add 4x and -4x, and what do you guys get? Now, is 0x x? Nope. 1x is x, correct? 0x is 0 or nothing. It cancels out. So on the bottom here, you have no x's left. And as you're writing this down in your notes, I want you guys to think about, what did that mean earlier this year? We learned how to solve multi-step equations. And when the x canceled out and we had a true sentence, it meant something. Remember, that was a magic trick lesson that day. Remember I showed you that magic trick? What did that mean? It was called an identity. But what's our solution for identities? You have two options. Either it's all real numbers or no solution. Caden, do you remember? All real numbers, right? Now, that's what this means if we were solving this equation. But this is not just an equation. It's one step in a system. So what do you think this means for a system of equations? A system is two lines on the same, and the solution is where those two lines hit. We're supposed to get our x and our y, but our x's cancel out, so we don't know what x is. What does it mean if this is true? What do you think it means? Eli? It makes both of them true? Well, if it said x equaled 2, then yes, you'd be right. But there's no x's. That's a problem. Caden, what do you think it means? That's a good guess. If the lines intersect at the origin, right there, then my x would be 0, right? And this would have said x equals 0, but we don't even have an x. So, normally this means all real numbers, which is how many solutions? Infinitely many. So if these guys cross more than one time, if they cross infinitely many times, what would that mean for the two lines? How is that possible that they can intersect infinitely many times? Matt? It's the same line. This line up here, if you were to graph it, would look something like this. And then if you were to graph this line, I'll do that in blue, they'd be in the same spot. So they intersect here, 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 infinitely many times. Does that mean everything is a solution to this system? No. Why not? Why do you think it means that doesn't mean that? Tucker? Okay, possible. But there's also an infinite number that are just rational. Kaden? Okay, so every point on this line is an answer, right? All these x's and y's. But what about all these points out here? None of those are answers. The solutions is every x and y coordinate on this line, which is how many? Infinitely many. But the difference between a system and just a regular one equation is, for a regular equation, everything's an answer. That's called an identity. All real numbers are the answers. But for a system, when it looks like an identity, it doesn't mean everything's an answer. Just everything on the two lines is an answer. So how do we answer this? This is what it looks like. We say infinitely many solutions because it's the same line. But the difference between this infinitely many and just solving a regular equation, it's not a system, is not everything's an answer. Just everything on the line is an answer. Okay, so you guys finish your notes. So what we learned today is a special case. We learned a special case when solving a system of equations that looks like an identity. But what it means is both of the lines are in the same spot, and the answer is, we don't put just the x and y, we say this, infinitely many solutions. Or in other words, it's the same line. But it doesn't mean everything's an answer, only the stuff on the line is an answer to the system. All right, can I get a question? Where did I first lose you guys? Which line, we'll call this 1. Oh, nope, I'm sorry. We'll call this 1, 2, 3, 4, 5. Which line is a little confusing to you? Raise your hand, let me know, guys. Yes, sir. Well, it's every point on those two lines, which is the same line. But there are so many points on one line that you can never, not even a computer could ever name them for all of human existence, because it's infinite. Right? So let's say this is our line, right? There's a point here. I'm just making this up. It's not true for this. I can do all the math. It's going to take too long. Let's just say negative 2, 2 is a solution. And then a negative 2, 1, a negative 2, 4. But in between these 2 points here, there's an infinite number of points here, 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 here that we can do that are also solutions. It's every single point, but it's none of these points outside over here. None of these points right here. Let's say this one is negative 1, negative 6. This point is not on the line, so it's not a solution. Did that make sense? Okay. Can I get another question, guys? Okay, so let's do this. Let's get through the lesson because it's a short day. Let's get through the lesson. And then I'll tell you what we'll do after that, okay? Let's do one more special. Yes, sir. Question.
Is there a sign or a symbol for this in math? Just like
For this, you mean? Infinitely many solutions. I just write it out. If you wanted to get fancy, you could put this is a symbol for infinite. So you could put infinitely many solutions. If you wanted to abbreviate real fast, I could put infinite solutions like that if you wanted to be quick about it. I'm not saying that's official, but that's what I would do if I was in a hurry. Okay, so what does this mean? X's cancel out, same number on both sides. My answer is infinitely many. Everybody good? Okay, there's another special case. Copy this in your notes, please. And this will be our last one for the day and for the semester. Last note problem in our notes. And then we'll probably do some hacker or something after this, okay? But I do have to, if you wonder why I'm not practicing much today and working with your neighbors, I'm recording this right now for the students that aren't here, so because I'm not sure if the book is clear about teaching how to do these special cases in lesson 3 of your book, so that's why I have to make a video for the absent students. All right, you guys finish copying that for me, please. So we're going to solve the system. In other words, I'm going to find where these two lines intersect each other, or the number x and the number y, that if I put it here and here, will make this equation true, and if I put it here and here, it'll make that true also. That's a solution to a system. So how do we do that? We use the substitution method. You guys remind your neighbors right now, what has to happen before we can use the substitution method? Ask your neighbors real quick. What has to happen? What do you have to have before you can substitute? Ask somebody. What do you guys have to have? You have to have what? What do you guys think? What do you have to have? Make sure you guys find out right now.
What was the question?
Ella, I picked your stick. Make sure you find out. So make sure you're asking your neighbors right now. If you get it wrong, we're all going to stand up and say it 5 or 6 times. Huh? Who knows? Ask him. He knows. He raised his hand. Ask him. One of the variables. Ethan, you're a good man. Thank you, sir. Okay? All right. So let me pick a stick. Stick is Ella. Ella, what do we have to have before we can use the substitution method? That's right. Very good. Caden, mask real quick, bud. So you guys have to take one of these equations, and you have to either isolate this x or this y, or on the bottom, this x or this y. Tell your neighbors, which one would I do? Tell them why. Yeah, there's no coefficient for that y. That's the one we want to do. The others would work. It's just going to be a ton more work because you're probably going to have fractions. Okay? So I'm going to take the bottom equation and isolate the y. What do I do to both sides? What's the name of the property I'm going to use right now? Someone say it out loud. Good man. Addition property of equality, because I'm adding to both sides, and my computer has frozen on me. I love it. There it is. Okay. So I add 2x to both sides. Another volunteer, especially if you haven't said anything yet today, maybe you're bored, maybe you're tired, maybe you just don't like Mr. Carbajal, whatever the reason is for you not talking, I want you to raise your hand and tell me what's going to be the next line. Someone tell me that. What's going to be the next line? Volunteer, raise your hand if you don't want to raise your hand. That's got to be you. No, everyone raising their hand has already spoken today. Yes, ma'am. That's exactly right. Perfect. Thank you. Put that in your notes. We took this line and we isolated y. Now we can substitute. Guys and girls, remember, please, you got to plug it back into the other one. Who can tell me the next step? What's the next step going to say? So let me pick somebody randomly. Okay. How about B5? Hey, Alana. Can you do me a favor, Alana, and read this line here to me, but instead of saying y, substitute this stuff in where the y goes? Very good. Now, we're going to say this again, but instead of y, we'll put 2x minus 1 in parentheses, right? But it looks like I already did rule for subtraction. Good thing. I still got to do it here, though, don't I? Did I skip? I skipped that step. I don't know. Something wrong with me when I wrote this lesson. I should have did rule for subtraction next. This is our next step. I'm going to do add the opposite. Minus 2 means plus negative 2. Am I right or am I right? Just say I'm right. Thank you. All right, so now I'm going to distribute this negative 2. Tell your neighbors real quick, how do we solve equations? What are the 3 steps? Say it right now. What are the 3 steps? Ask your neighbor. Simplify. Variables together. Isolate. Now, ask your neighbors, how do you simplify? Everybody say it. Distribute, combine like terms. Say it. Good, good. So I'm going to distribute first. Now, I'm not doing this 4x plus yet, am I? So I copy that down, 4x plus. Now I distribute. Negative 2 times 2x is negative 4x, right? Now we have to do negative 2 times negative 1. Isn't negative times negative positive? and then we just copy the other stuff down that we're not using. Everybody okay? You said distribute combine like terms. You guys combine like terms right now. What do you guys get? Austin, are you awake over there? Just making sure. Sit up for me, bud. Thank you, sir. You're making me sleepy looking at you. All right, so you guys go ahead and tell your neighbors what's going to happen now. Our x's are going to what? Cancel out. How is this different from our last problem? This is false. Normally when we solve these, we would say this is false. This is not an identity. This is not all real numbers. This is not infinitely many solutions. This is no solution, right? Now think about it. I'm going to give a mint if you guys can answer this. If we have a system of equations, that means two lines. The solution means where the two lines hit. If we're solving our system and we end up with something weird like this, what does that mean for our two lines? You guys think about that. I'm going to pick somebody randomly, and if you're right, I want to give you a minute. Think about it. You guys can talk to each other, actually. What does it mean for our lines? What does it mean for our lines? Okay, closest to F6. Tucker, you're closest enough, raising his hand. Yes, sir? And what do you call two lines that don't intersect? Oh, you're so close, my man. I want to give it to you, but you have to say it. You don't know? The lines are what? Not sure? Oh, I feel badly. You have to say it, though. The lines are what? How about closest to B3? Closest to B3, I guess would be A3. Yes, ma'am. True. They never cross, but what are those lines called? What are lines called that never intersect and never cross? C6. Tori. Yes. I like Eli's better. Non-crossing lines. Non-crossing lines, also known as parallel lines. So think about it. This line here, let's say it looks like this. This line here looks something like this. These lines, if they're parallel, are never going to touch, are they? Those are called parallel lines. So if two lines are parallel, they can't share any points, can they? So which means there's no solution. There's no one point that will make both of these true. There is no one point that both lines go through because these two lines are parallel. How do we know that? We did the substitution method. Our x's canceled out. And instead of them being the same line, when these numbers are the same, they were different numbers, which means they're parallel lines. So I need you guys to finish your notes. No solution, because the lines are parallel. That's why there's no solution. How do we know they're parallel without graphing? This happens. No x's, false, parallel lines. No solution. Okay, let me go ahead and number my steps here while you guys finish your notes. And I want you guys to tell me the first line that is confusing. Which line confused you a little bit? Which one? 1 through 8. Which one? All right, so we'll go ahead and talk about whatever practice or what we're going to do now. I just want to end this lesson for the people that are at home. So let me go ahead and exit out of this.